Hello, plot the following points on a coordinate system. 2, -3, so that means 2 in the x-axis, and then 3. B is -3/2, 4, so 3/2 should be there, and up 4. 1, 2, 3, 4. 4, 8. So there's 4, 1, 2, 3, 4, 5, 6, 7, 8. It's kind of a little bit off of our graph. Then -5/2 and -7/3. So I'm going to do 2 halves here, 4 halves, -5/2, and then down -7/3. So there would be -3/3, -6/3. Be right about there. -5/2, -7/3. Find the exact distance and approximate to 3 decimal places between the points -1, -3, and 3, -7. So 3 minus -1, quantity squared, plus -7 minus a -3, quantity squared, and take the square root of that. So that's going to be 4 squared plus -4 squared. So we're going to get 4 squared times 2. With that square, we can pull that out, so you get 4 square root 2. So that is the exact distance. And then the approximate, we would put that in the calculator and get 6.5. Calculator says 6.8, so that round up to 7. 3, find the midpoint of the line segment with endpoints -7, -4, and 2, 6. So for the x values, we do -7 plus 2 divided by 2, and for the y values, we do -4 plus 6/2. So we're going to get -5/2. Over here, we're going to get 2/2. So the midpoint is going to be -5, comma 1. Identify the set of x values in an interval notation for which y will be a real number for each of the following. 4 over x minus 5. So there we have a denominator that could equal 0 at one point. That point will be at x equals 5. So the set of x values for that one will be from -infinity to 5 union 5 to +infinity. For part B, we have the square root of x minus 10. So any real number will be positive under the square root. So x minus 10 is equal to 0, x equals 10, and we're going to need it to be greater or equal to 10. So the interval notation for that will be a bracket 10, comma, infinity. For part C, we have a y equals 3x plus 7. There's no values from -infinity to infinity. That'll cause that to become non-real. D, we have y equals 2 over the square root of 10, or x minus 10, which is very similar to B, but now that square root is in the denominator, and when x equals 10, we get an undefined. So it'll be in open parentheses this time, but on to infinity. find the x and y intercepts for the following equations. So for part A, we will find the y-intercept by plugging 0 in for x. So we get 2 times 0 minus 4y is equal to 12. Negative 4y is equal to 12. Y is equal to negative 3. As a reminder, that's the y-intercept. Then for the x-intercept, we will set y equal to 0. So you get 2x is equal to 12. X is equal to positive 6. B, y is equal to the absolute value of x plus 4 minus 3. Do, again, the y-intercept, that's whenever x equals 0. Absolute value of 0 plus 4 minus 3. Yep, y is equal to 4 minus 3, or y equals 1. Then for the x-intercept, we'll set y equal to 0 and solve for our x. So add 3 to both sides. But now we have x in the absolute value, so we get negative 3 is equal to x plus 4. Or we get negative 7 is equal to x. And then we get 3 is equal to x plus 4. Where we get negative 1 is also equal to x. So in this case, we have 2 x-intercepts. So see, we get y equals x squared minus 4. So again, for the y-intercept, we'll plug in 0 for x. So the y-intercept is negative 4. Now for the x-intercepts, we'll set y equal to 0. Add the 4 over to get x squared. And then we'll take the square root of both sides. And we get plus or minus 2 is equal to the x-intercepts. And this last one, we get x is equal to y squared minus 9. So to get the y-intercepts, we set x equal to 0. We'll add 9 over, take the square root. So plus or minus 3 is the y-intercept. And then the x-intercept will be x equals 0 squared minus 9, or x equals negative 9. All right, graph the equation y equals x squared minus 2x plus 1 by plotting points. Use the table with a minimum of 6 points. So we do our x and our y. We'll start at, I don't know, negative 2, negative 1, 0, 1, 2, 3. There's 6 points. And we'll start plugging them into our calculator. So at negative 2, we should get 9. Negative 1, we'll get 4. At 0, we should get 1. 1, we should get 0. At 2, we'll get 1. And then at 3, we will get 4. All right, so it looks like we need kind of a height of 9. We don't dip below the x-axis. So we can do something like this. Call that our x. And we'll call this our y. And then we can start plotting those points. So negative 2, 9. So negative 2, 1, 2, 3, 4, 6, 7, 8, 9, negative 1, 4, 0, 1, 1, 0, 2, 1, and 3, 4. Given the equation of circle in standard form, find the center and radius of the circle. So the center of the circle will be at negative 3, positive 2. We get that from this x plus 3. We'll switch the signs, and then that x minus 2. Again, switch the signs. And then the radius is equal to that value. Radius squared is equal to that value. So r is equal to 5. Normally we'd say plus or minus 5, but since distances have to have a positive value, we only take the positive. Write an equation of a circle defined by x squared plus y squared plus 12x minus 14y plus 84 equals 8 in standard form. And then identify the center and radius of the circle, show all work. Write that up here. Okay, so we're going to come to this, group all the x's and group all the y's together. Plus 84 is equal to 8. Now we're going to do completing the square for both our x's and our y's. So it'll be x plus 6, quantity squared, minus 36, plus y minus 7, quantity squared. Remember, we take the half, and then we're going to have to subtract off the square of that, minus 49, plus 84 is still equal to 8. Start collecting up like terms. Minus 1 is equal to 8. Is equal to 9. All right, now we have it in standard form. We can read off the center and the radius. So the center is negative 6, positive 7, and then the radius squared is equal to 9, so the radius is equal to 3. Write an equation in write the equation of a circle in standard form with center of negative 5, positive 2, and a radius of the square root of 12. So the standard form, we would get x minus a negative 5, all that squared, plus y minus 2 squared is equal to the square root of 12 squared. And if we simplify that down, we get x plus 5 squared plus y minus 2 squared is equal to 12. Write an equation of the circle in standard form given that the endpoints of a diameter of the circle are 7, 3 and 5, negative 1. Okay, so you need to find the center and radius of it from those 2 points. So how we find the center is we take the midpoint of a diameter. So we'll get 7 plus 5 over 2, and then 3 minus 1 over 2. So the center is located at 6, 1. And now to find the radius, we need to find the distance between the two of them, but we need to remember that this is a diameter, so once we find that distance, we would need to half it to get the radius. So 7 minus 5 squared plus 3 minus a negative 1 squared. Take the square root of that. So we'll get 2 squared plus 4 squared, 4 plus 16, all that square rooted, square root of 20, and that reduces down to 2 square roots of 5. Now remember, this is the diameter. So that means the square root of 5 will be the radius whenever we divide the diameter by 2. So now we can write the standard equation, or this equation of a circle in standard form. X minus 6 squared plus y minus 1 squared is equal to the square root of 5 squared. And if we simplify that, we get x minus 6 squared. Y minus 1 squared is equal to 5.
Okay, number 11, we're going to write an equation of a circle in standard form with the center -2, -1, and a point on the circle as 6, 5. Show how it work. So first thing is, let's write out what the standard form is. So we're going to have y minus some k squared equals our radius squared. So we're given these 2 points here from the center, which means that we can fill those in right away. We know that we're going to have x, sort of a minus -2, which becomes plus 2 squared, plus y minus -1 becomes plus 1 squared equals our radius squared. So now we need to figure out what goes right here. And to do that, we're going to use this point that we were given. So if I plug this point in, then I'll have just r as an unknown, and I can solve. So if I plug that in, I'm going to have 8 squared, and then I'll plug 5 in for y, 6 squared equals my radius squared. So this is 64 plus 36 equals my radius squared. So this is 100 equals my radius squared. So our radius of the circle is going to be 10. So from here, what we're going to do is just come back up to here with this and plug it in, and we're good. So in standard form, this will be x plus 2 squared plus y plus 1 squared equals our radius of 10 squared is 100. And we're done. Okay, starting with number 12a. For each of the following, determine if the relation defines y as a function of x. So in order for y to be a function of x, we can plug in one x value, and for this x value, there exists only one y value. Basically, it just means that if I plug in some number for x, I expect to get only one number for y, instead of 2 or 3 different possible y values. So a good way to check this visually on a graph is with what's known as the vertical line test, which basically just states that we take some vertical line and we pass it through this graph, and we look if this vertical line is ever able to touch the graph at 2 different points. So you see here that as we pass it from side to side, that it will only ever touch one single point on the graph. So because of that, that means that it passes, and that this is a y as a function of x. So I'm going to put a little check mark that it's good. The next one, b, I have x squared plus y minus 3 equals 4. So a good way to approach these, if you're given an equation, is let's try solving for y, just to see what happens. So if I solve for y, I get that x squared plus y minus 3 equals 4. So I can move the 3 to the other side, and then I can subtract x squared. So we have an equation for y in terms of x, and notice how if I plug in an x value, let's just say 1, I'm only going to get the one y value. There isn't anything that's going to mess this up. And we can even imagine what this would look like on a graph. And that would also pass the vertical line test. So this one here gets a check mark. So next one, C, we have some inputs here. So we say if I input -3, that's going to correspond to an output of 11. And if I input -6, it's going to correspond to an output of 13 or 9. Well, that's kind of an issue because in order for this to be a function, for every input, there has to be only one output. So this one here, because this -6 could equal 13 or it could equal 9, or the output of -6, this one here is does not define y as a function of x. So last one, we have x squared plus y squared equals 6y plus 9. Again, let's try solving for y and seeing what happens. So if I start just by moving the x squared to the opposite side, I'll have something like this. Now notice this here is able to be factored nicely, so let's factor that. So we have y minus 3 squared equals 4 minus x squared. Okay, so now the next step would be to take the square root. If I do that, I'll have y minus 3 equals the square root of 4 minus x squared. But whenever I take the square root, remember one thing that we always need to do is put a plus or minus. So then if I finish solving for y, I get that y equals 3 plus or minus the square root of 4 minus x squared. Okay. Now we should start seeing alarm bells here. Because if I plug in, let's just say 0 for x. If I plug in 0, I'll have, so y of 0 is going to equal 3 plus the square root of 4, which is 2. But it could also equal 3 minus the square root of 4, which is 2. So we got two different outputs for this one input. Oops, sorry. So because of this, D is not a function. Okay, number 13, use the vertical line test to determine if the given relation defines y as a function of x. So again, just like the last one, we're going to take this vertical line, and as we pass it through, in order to pass the vertical line test, the line should only touch the graph at one point. So we can see here on part A that our vertical line is touching at two different points at the same time. So because of that, it means that y is not a function of x. So this one here does not pass. If we move on to the next one, B, so I move this along, it only ever touches at one point. So this one here is good. So for this one, y is a function of x. Then for C, you do the same thing. As we pass it along, it seems good. But there's a point where something happens. It's right here. And at this spot, there's a little bit of an issue because we see that both of these are closed circles, which means that at x is -2, y equals both 2 and 4. And because of that, it means we do not pass the vertical line test, and y is not a function for this graph. Okay, 14. Given the following functions, f of x equals x squared minus 2x plus 3, g of x equals 2x plus 1 over 3x minus 2, and h of x equals the square root of 2x minus 5, evaluate each of the following. Starting with g of 4, we just plug in 4 wherever we see x. This will be 2 times 4 plus 1 over 3 times 4 minus 2. So g of 4 is going to equal, on the numerator, we'll have 9, and in our denominator, we'll have 10. So g of 4 is going to equal 9 over 10. And for the next one, we have f of negative 3. So if I plug in negative 3 wherever I see x, I'll have negative 3 squared minus 2 times negative 3 plus 3. So this here will be 9. This here will be 6. And this here will be 3. So we're going to have 9 plus 9 is 18. So f of negative 3 equals 18. For f of 3, so now we're going to do the same function, except we're going to plug in positive 3 wherever we see x. So we'll have 3 squared minus 2 times 3 plus 3. So this will equal 9 minus 6 plus 3. So here, we're going to have 12 minus 6 is equal to 6. So f of 3 equals 6. Last one, h of 15, is going to equal the square root of 2 times 15 minus 5. So this here is going to equal the square root of 30 minus 5, which is 25. And the square root of 25 is just going to be 5, because if I square 5, I end up with 25. So h of 15 is equal to 5. Okay, 15, starting with a, we're going to determine the x and y intercepts of the following functions. So for the first one, in order to find the x intercept, what we're going to do is set y equal to 0, or mx equal to 0. So we're going to say 0 is equal to 4x minus 12. And if I solve this out here, I'm going to get that x is equal to 3. So this here is my x-intercept. Now for my y-intercept, I'm going to set x equal to 0. So I'm going to have m at 0. It's going to be equal to 0 minus 12. So m at 0 is equal to negative 12. Again, moving on to my next function. For my x-intercept, I'm going to do the same thing. I'm going to set y equal to 0, or p of x equal to 0. So 0 is equal to the absolute value of x minus 5. So what we can do here is we can kind of just look at this and know that x has to equal plus or minus 5. But I guess a more algebraic way is to say 5 is equal to the square root of x, or excuse me, the absolute value of x. And then we can kind of undo that absolute value by saying that x is equal to plus or minus 5 here. So these are our x-intercepts right here. And for our y-intercept, we're going to set x equal to 0. If we do that, we get that p of 0 is equal to 0 minus 5. So p of 0 is equal to minus 5. And this function here might be a good one to double check graphically as well. So if I try and graph it here, this is my x-axis and my y-axis. So I know square root of, or excuse me, absolute value of x is going to do something kind of like this here, some similar shape. But we also translate it 5 spaces downwards. So what that's going to look like is maybe something kind of like this. So from here, we can see that we're going to get that negative 5 point here on our y-intercept, and our x-intercept is going to be at plus or minus 5. And we can also always double check just by plugging in those numbers and making sure that everything works. But yeah, these are our values for the x and y-intercept. Okay, number 16, we're going to find the domain of the following functions in interval notation. So this is something that you're going to see a lot. So I definitely make sure that you understand how to do this, and as well as what it is conceptually. So I think the most easy explanation is if I look at something like y equals the square root of x. If I plug in x is equal to, say, negative 1, y is equal to, well, the square root of negative 1, which is not a real number. So basically, whenever we're looking for domain, we're looking for these sort of like errors or spots where if I plug in an x, I don't have a y. So domain is just the set of x values or inputs that get you an output. And there's sort of like different things to look out for, or different sort of like, I guess, like red flags. So for the time being, the ones that you want to look for most is something like 1 over 0 and the square root of a negative number. These are things that we can't have. So because those are what we're going to avoid, it's always a good idea to try and find where those occur. So looking at this first one with x plus 2 over x minus 3. So we want to make sure that this denominator here does not equal 0, because that's where we're going to have some does not exist for y. So notice how if I set x minus 3 equal to 0, I can solve this and say, well, at x equals 3, this here will equal 0, which is going to be an issue. So at x equals 3, we can't have that because we won't have a y. So our domain, we can plug in any other x value. There's nothing else limiting this. It's only just that this here can't equal 0. So our domain, if we were to express this on interval notation, so again, all numbers except for 3. The way we write this is we go, well, we can plug in anything from negative infinity to 3, but we can't have 3, so we're going to put a parentheses. And we're going to have some other set, so we're putting a union to say that it's this set, basically, as well as some other set is included in it. And we go from 3 all the way to infinity. It's all good. So with regards to parentheses versus brackets, anytime it's infinity, you're going to put a parenthesis. So if it's a spot that is not included, like this 3, x cannot equal 3, we use a parenthesis. If you have something like it could equal 3, then you would use a bracket in that case, and we'll see that come up. But so for the first answer, our answer is going to be for the domain negative infinity to 3 union 3 to positive infinity. Okay, for square root 5 minus x, so really what we're looking out for is that the square root of x, we know x must be greater than or equal to 0. So we can sort of make the substitution that 5 minus x must also be greater than or equal to 0. And we see that 5 must be greater than or equal to x, or another way of thinking about it is x must be less than or equal to 5. So anything that's less than 5 is all good. If I plug in 6, 5.0001, we can't do that. So we can't plug in anything greater than 5, because otherwise we'd have square root of a negative, which we don't like. So the way that we're going to put this in interval notation, so we always start with the smallest number that we're able to plug in, which is negative infinity. And then as we move up, we eventually reach 5. And at 5 we have some sort of issue, but we're allowed to plug in 5. So because if I plug in 5, this still works, because again, square root of 0 is just 0, so there's no issue with plugging in 5 here. But anything greater than 5 we can't plug in. So this here is it for our domain. Okay, for h of x, 4 for the square root of 5 minus x. So now we're taking both those issues that we previously had and we're kind of putting them into one. So you know that our denominator can't equal 0. And we also know that we can't have a negative inside of a square root. So I'm going to take each one of these one at a time. So I know that the square root of 5 minus x can't equal 0. So what I find is that x cannot equal 5. The other thing is I know that the square root of x, x must be greater than or equal to 0. And in this case, I have the square root of 5 minus x. So 5 minus x must be greater than or equal to 0. So using that same logic from the last question, we find that x must be less than or equal to 5. So now we have to put both of these two together. And if I do that, I find that I can go from negative infinity all the way up to 5. But now if I plug in 5, notice if I plug in 5 here, I'm going to have the square root of 5 minus 5, which is 0. So now I would have 4 over 0, which is not something that we want. So because we can't plug in 5, I'm going to put parentheses here. And then because of this, we can't go beyond 5, because otherwise we would have a negative in our square root. So because there's nowhere else that x can exist, this here is our domain. Okay, last one, s minus 2 over x squared plus 4. Oh, sorry, x minus 2. So again, same thing, we can't have a 0 in our denominator. So we can say x squared, x squared plus 4 cannot equal 0. So we get x squared cannot equal negative 4. Well, that's never going to happen anyways, because we will have a square root in a negative, or excuse me, a negative in a square root. So because this bottom part here is never going to equal 0, we're never going to have any sort of errors or discontinuities or something like divide by 0. So we can go ahead and say that our domain is all real numbers. So I guess in order to write that in interval notation, what we can go ahead and do is say that we can go from negative infinity all the way to positive infinity. And we'll never have any issues between those two. Okay, 17. Use the graph to determine f of negative 2. So f of negative 2 is going to be our y value whenever x is negative 2. So if I go ahead and look here, that's negative 1, negative 2. So f of negative 2 is equal to negative 2. I'm going to write these out to the side, actually. F of negative 2 is equal to negative 2. Okay, determine f of 3, same thing. I'm going to look for where x is 3, I'm going to find my line, and I see it's at negative 1. So for part B, f of 3 is equal to negative 1. For part C, we're going to find all x for which f of x is equal to negative 1. So if I look here at negative 1, well, I already found one of them, is that x is going to equal 3. But there's this other one over here. So whenever y is negative 1, we have this point, and we have this point, which corresponds to with x being negative 1. So I have two answers here. D, find all x for which f of x is negative 4. Okay, so I come down here and look at negative 4. Well, the only time that our graph reaches negative 4 is this point right here, which is also at x is equal to negative 4. And notice over here on this side, it's not extending this way. It stops and starts going this way. So f of 5, for example, is just going to be negative 2. So it's never going to reach negative 4 on this side here. So our next part, E, we're going to determine the x-intercepts. So the x-intercepts are where we touch the x-axis. That's going to be here and here, which corresponds to an x equaling 2 and an x equaling 0. We can see that x equals 0, we're at the x-axis. X equals 2, we're at the x-axis. So F, determine the y-intercept. So we actually found it. It's, whenever we're along this line here, or y-axis, whenever we cross that, so that happens right here, whenever y is equal to 0, which coincides with this point here. So G, we're going to find the domain of f. Well, if I look, I can plug in any x value, and I'm always going to get a y value. No matter what x value I plug in, I have a y. So because of that, we never have any issues. So we say we go from negative infinity to positive infinity. And lastly, H, this is probably the trickiest one. We're going to find the range of f. So the range is the set of all possible y values, and in interval notation, we write that from smallest to most. So if we notice here, our y values can go on and on and on until they reach negative infinity on this side here. But if we try increasing y, well, we're never going to reach y equals 2. We're never going to reach y equals 1.5. We never actually reach anything past y is 1. But we do find that y can equal 1 at x equals 1. So our range, our smallest y value, is negative infinity, and we can go all the way up to y equals 1. We found that y equals 1 is a point on this graph, so we're going to use brackets. And that's it.
Okay, now we will be doing question 18. We're going to graph the line represented by 2x plus 5y equals 10. So we're going to create a table and use at least 3 points. So let's first start out with what our slope is going to, finding our slope. So let's reorganize this equation and get it to where y is by itself. So we have 2x plus 5y equals 10. We're going to want to move over this 2x onto the other side. So we'll have 5y equals 10 minus 2x. Then we're going to divide by this 5 to get y by itself. So let's see what these are separate. We have 10 over 5 minus 2 over 5x. So y equals 2 minus 2/5 x. Now we're going to create a table to see where these points would line up on this graph that we're going to make. So we'll have our x's here and our y's here. So let's just pick simple points that we think would look good. So I'm going to pick 0, and I'm going to pick 2, and I'm going to pick 5. The reason why I pick 0 is we see that this term could go away. I choose 2 to be a random number, and 5 can also make this fraction cancel out. So let's see what we can do with these 2 points. So we have 0, so then we have 2 minus 2/5 times 0. So that gets rid of this term, and we'll just have 2. We're going to use 2. We're going to have 2 minus 2 over 5 times 2. So 2 minus 2/5 times 2 will equal 2 minus 4 over 5. So this would actually turn into 2 times 5 over 5 minus 4/5. So this will be 10/5 minus 4/5, which will equal 6/5. And then we have 5, which will be 2 minus 2/5 times 5. So these two will cancel out, and I'll get 2 minus 2, which will equal 0. So now let's graph this. So now I'm going to use the quadrant that's in the positive x and y, just because we get positive numbers when we do this graph. So negative x is that way and negative y is this way, but we won't be using those, so that's why those are a little smaller. So for 0, I'm going to have a point 0 here. So at 0, which is right here, I'm going to go up to 2. So this is at 2. And then we're going to go over, and we're going to go over to 2 and 5. So at 2, we have it as 6/5. So if I divide by 5, that's 1.2. That's what this looks like. So at 0.2, this we're going to go up to about here, and we're going to know that this is at 1.2. And then we're going to go over to 5, and we know this equals 0. So let's connect these dots. And we should now have function that equals at this line's representation. So this line will be y equals 2 minus 2/5 x. And this is what this graph should look like. If you would like to get more points, you could plug these points into the equation and find those where it's in the more negative or the more positive, and that should show where these lines continue. Okay, we're going to be doing question 19. We're going to determine the slope of the line passing through the points -5, 2, and 2, -4. So let's first start out with an equation. M equals y2 minus y1 over x2 over x1. M is going to be defined as our slope, and y2, y1, x2, and x1 are going to be points that we're going to gather. So they gave us the points -5, 2, and the point 3, -4. So -5 will be our x1 that we're going to identify as, and then the paired one with that will be y1. and the 3 will be considered our x2, and the pair with that, which in our y, will be y2. So let's plug into this equation. Y equals y2, so y2 in this case will be -4. And then for the next one will be y1, which will be 2, over x2, which x2 will be considered 3, and x1 will be considered this one here, -5. So let's get that in a separate table so it looks a little better. -2 minus 2, and we have 3 minus a -5. So we see here we have 2 negatives, so we can now turn that into a plus. So we have -4 minus 2 over 3 plus 5. So this will be -6 over 8. And if we simplify that, we can have -3 over 4. Now this should determine our slope at this point. If we wanted to consider a full equation, we would have to use our point slope form. But for this question, it is only going to ask what the m value in such equation for this would be. So that is our slope. We're going to now be doing question 20. It's asking for the slope and the y-intercept. So we see that we would want it in the form as y equals mx plus b, where m is our slope and b is our y-intercept. So now we want to rearrange this equation so we can have this y by itself and these in this form. So we have 2x minus 3y equals 9. So let's get y by itself. First, we want to take this minus 2x, because whatever you do to one side, you do to the other. So now that we have that, we have -3y equals 9 minus 2x. We're going to divide by -3. And now we want to split this, since these are the same. Divided by that 3, we'll just split these into this. So now that we have this, we have these 2 negatives. Now we can make this a plus, but we also can simplify here. 9 divided by 3 is 3, and we have this negative still. So we have y equals -3 plus 2/3 x. So now this is not exactly in the y equals mx plus b form as you usually see it flipped around, but we can just rearrange that and make it y equals 2/3 x minus 3, so that it looks a little bit more like the equation. So now we have found the slope, which is this m part. So now we know that the slope, m, is 2/3, and we know that this y-intercept is -3. Now we have the slope and y-intercept of this equation. Okay, now we will be doing question 21. Find the slope of each of the following. Let's start with part A. So for part A, we're given a line that passes through these certain points. So we have the point 1/2, 4, and 3 1/3. So since we're given points, we're going to want to have to find slope, which is y2 minus y1 over x2 minus x1. And we're also going to have to use one of these lines, so we have to use the points to find the slope. So we'll define our x1 as this first point, x value, and then we'll define the y1 as your first y value. And then we'll do the same here and make this your x2 and your y2. So now that we have that, we can plug straight into this equation. We can have your y2, so we're going to select 1/3 minus your y1, which is 4, and then we have x2, which is 3, and then we're going to have y1, your x1, which is 1/2. So now that we have that, we're going to have 1/3 minus 4. So let's look at this. These are fractions, and sometimes fractions look a little wonky trying to do them with whole numbers. So we're going to actually transform this whole number 4 into that fraction. In order to do that, we can just times it by 3/3, because if we do 3/3, 3/3 itself equals 1. So then we can have this in a fraction to where it looks like a third is on the bottom. So we have 1/3 minus 4 times 3/3, seeing this 1 is there. So 4 times 3 is 12, so we have 1/3 minus 12/3, which should equal -11/3. So then we also have this bottom form where we have 3 minus 1/2. So let's turn this 3 into a fraction and do 2 times 3/2. So then these could cancel out to make that minus the 1/2. So then we have 6/2 minus 1/2, which equals 5/2. So now we have negative 11 thirds divided by 5 halves. So negative 11 thirds divided by 5 halves. We know we can do keep, change, flip, which is we keep the first one. We change this to a multiply symbol, and we make this like that. And if we times those, we get a negative 22 over 15. Now we know that our slope will be negative 22 over 15. Okay, let's do part B. So for part B, we're going to do one of a slope of a vertical line. So let's draw out what a vertical line would look like on a graph. Let's call this a point at 2. We're going to draw a vertical line here. So at 2, we could pick a point upon this line, and we could do 2, 2, and we could do a point here, 2, 1. So on this, we want to use m equals y2 minus y1 over x2 over x1. So let's plug in these points. We'll consider this our 2 point, and we'll consider this our 1 point. So for y2, we have 2 minus y1, which is right here, 1, and then x2, which will be this one, minus x1. So when I get that, I get 1 over 0. We don't like that because we're actually not getting a number out, and that actually tells us a number over 0 places this slope as undefined. So when we have an undefined slope for this, that tells us that our x values will always be the same. So no matter what you plug into this equation for y2 and y1, these x's, being that these x's will always be the same, you'll always get a number over 0. So this y2 and y1 could never have 0 over 0, which would give us 0, because that would mean that y2 equals y1, which would mean that we'd have a point on this graph and we'd be doing that point again on this graph, which would mean we would just be doing at a point. It actually wouldn't be a line, it'd just be a point on this. So no matter where you have this, we have this being at negative 2, these x values will always be the same, which means that we'll always get an undefined slope with a vertical line. Okay, let's do part C. A line defined by 5x plus 4y equals 20. So we most likely want to get this in the y equals mx plus b form, which you could do this in another way, doing points, but the simplest way is to do it this way. So we want to get y isolated by itself, and then we should get two terms, m, which would be our slope, and b being our y-intercept. So let's get y by itself. Let's minus this 5x to the other side, because what we do to the other one side, we do to the other. And then we'll get 4y equals 20 minus 5x. Let's divide by 4 to get y totally isolated. So then we will have y, which will equal 20 over 4 minus 5x over 4. We did this because this has a common denominator, which means that we can split off these terms into two separate terms given this at the top. So now we'll have y equals 5, because 20 divided by 4 equals 5, minus 5x divided by 4. So now that we have this, we can make it look a little bit better, making it look like this, and have y equals negative 5x divided by 4 plus 5, which gives us the form that looks a little bit more like y equals mx plus b. So now we can find what this m and this b is. So m being our slope will be negative 5/4, and then we'll also have our y-intercept, which will be 5. We got a little bit more information getting our y-intercept, so we know exactly where this graph will hit at 0. It'll hit this 5. But now we have our now defined slope, which is negative 5/4. Okay, let's continue on to part D, horizontal line. So let's draw what a horizontal line looks like. I'm going to be using the point at 2, and this will be a horizontal line. This will be positive x, negative x, and y. So let's pick a point on this line, which we'll pick, say this is 1, 2, and we'll pick this point, which is negative 1, 2. So now that we have that, let's use the form m equals y2 minus y1 over x2 minus x1 to demonstrate this point. So for y2, we'll use this point, and for 1, we'll use that one. So y2 will be 2, and for y1, we'll use 2 as well. For x2, we'll use 1, and then for x1, we'll use negative 1. So now we have 0 over 2, which equals 0. So this point, for this horizontal line, we get 0. So let's try it out on another horizontal line. Let's say we have something at y equals 3. So now we have this, which will show, let's choose 1, 3, and we'll use negative 1, 3. Here's the thing, when I do that, the only thing we're changing in this is this top part, which will be 3 minus 3. So no matter what kind of line I get, being this number on the bottom, which is arbitrary in this point, we'll get some 0 over some number, which will equal 0. So no matter what, you'll get 0 for the slope. But we can also see this in the form when we have y equals mx plus b. We say that y equals some number for horizontal lines. We call it a constant line or a linear line. So for this one, we'll have to where we only get the defined point of b, which is the intercept and where it hits this axis right here. So this will be where we have this number will always just be a number, and you'll have like an arbitrary 0 in front of this x as the slope equals 0, which basically just makes this term go away. So that's how we know for a horizontal line that the slope is just 0.
Okay, now looking at question 22 here. I'm going to erase that and rewrite it. 22. Okay, a little buff. Get the function f of x is equal to 2x squared minus 3x plus 5. I'm going to find the average rate of change on the interval from 2 to 3. Then something to think about and try. The average rate of change of a function is the slope of the corresponding secant line. What is the equation of the secant line for the function and interval given in this question? So to find the average rate of change, we know our equation is average rate of change. It's going to be our y2 minus our y1 all over x2 minus x1. Well, we know our x2, our x1. We don't know our y's. So we're going to get that from plugging it into our equation. So y2 is going to come from plugging 3 into our equation. F of 3, which is going to be 2 times 3 squared minus 2 times 3 times 3 plus 5. Simplifying this down, we're going to get 2 times 9, 18, minus 9 plus 5. 18 minus 9 is 9, plus 5 is going to give us 14. And our y1 is going to be when we plug in 2 for x. 2 times 2 squared minus 3 times 2 plus 5. It's going to leave us with 8 minus 6 plus 5. 8 minus 6 is 2, plus 5 is going to give us 7. So if we write this in a coordinate, we're going to have y1 is going to be 2, 7, and another one is going to be 3, 14, right? So now what we can do is find our average rate of change. Average rate of change, y2 is 14 minus y1 is 7 over 3 minus 1. 14 minus 7 is 7. 3 minus 2 over 1. So we're going to have an average rate of change of 7. Writing this in an equation for our secant line that says to try, think about something. We can think about our equation y is equal to mx plus b, where m is equal to our average rate of change. So we're going to have y is equal to 7x plus b. We need to solve for this b value by plugging in a point that we know for our x and our y. So I'm going to use 7 or 2, 7. So 7 is equal to 7 times 2 plus b. 7 times 2 is 14. So we're going to have 7 is equal to 14 plus b. Subtract 14 on both sides. We're going to have b is equal to negative 7. So our equation is going to be y is equal to 7x minus 7. All right, now looking at question 23 here, we're going to use slope-intercept to write an equation of the line that passes through the points negative 8, 1, and 0, negative 3. So one very important thing first about this point is it says slope-intercepts. We first have to find our slope of m, also known as our average rate of change, or just our rate of change. So y2 in this case is negative 3 minus 1, y1 over x2, 0, minus a negative 8. So we're going to end up being left with negative 4 over positive 8. So that's going to leave us with m being equal to negative 1/2. Now we have our slope, we can write our equation. So slope-intercept form is y is equal to mx plus b. So once we have mx plus b, we know our m, we know an x and a y point, so we can plug those in to solve for a b value. So I'm going to use 0 and negative 3. So negative 3 is equal to m of negative 1/2 times 0 plus b. So our b is going to be equal to negative 3. And writing this equation out, we'll have y is equal to negative 1/2 x minus 3. And that is going to be our slope-intercept form. Now looking at question 24 here, we want to use the point slope from it to write an equation of a line passing through a point negative 3, 7 with a slope of 2/3. So point slope formula kind of looks like y minus the y that we know is equal to m times x minus the x that we know, right? So plugging this in, our y that we know is 7, so we're going to have y minus 7 is equal to our slope of 2/3 times x minus a negative 3. One thing is that we're going to add the 7 and simplify a little bit. 7, so we're going to have 2/3 times x minus a negative 3 is going to give us a plus 3. And then we're going to have plus 7. So now we just got to distribute our 2/3. So we're going to have y is equal to 2/3 times x, so 2/3 x, and then 2/3 times 3. Which is going to give us plus 2 plus 7. So that makes our equation y is equal to 2/3 x plus 2 plus 7, 9. That's going to be our point slope equation written in slope-intercept form.